This is my cue. Sally switched off the announcement. And good evening, ladies and gentlemen. And on behalf of the University of KwaZulu-Natal's College of Agriculture, Engineering and Science at ARI, I would like to welcome you to our first online talk in celebration of National Science Week. And before I introduce our guest speaker for this evening, just a few house rules, please. Please make sure that you have muted your microphone. And especially if you're at home, we don't want to hear any, sort of noise disturbing us. So if you don't know how to do this, at the bottom left of your screen, you need to have a crossed out microphone. Please also switch off your camera. We will have a question and answer session after the talk, and you can post questions in the chat. Just a quick introduction to basically what we are doing tonight. We are celebrating National Science Week. And National Science Week is an annual celebration of science, engineering, and technology, attracting thousands of learners and members of the public to workshops, science shows, and like in this case, online lectures, which are held at universities, schools, science centers, and public facilities countrywide. The Department of Science and Innovation leads this initiative, and the South African Agency for Science and Technology Advancement, NRF SASTA, is responsible for its implementation. Each year there is a different theme, and usually resolve around, it's a different theme, and activity usually revolves around a theme. And this year we have something very interesting. We are actually celebrating the role of basic sciences in the modern world. And I'm pretty sure we're going to see some exciting, and I wouldn't call it basic science tonight. Just let me now introduce our guest speaker for tonight. And it is an absolute great pleasure to introduce you, Dr. Sandile Cele. He's a laboratory supervisor at Africa Health Research Institute, ARI, in KwaZulu-Natal. Believe it or not, he's a KZN boy from Ndwedwe in the Molokolo area. Sandile's undergraduate degree was in biomedical sciences. He later went on to do an honors in medical microbiology and a master's in biochemistry at UKZN. Sandile joined Africa Health Research Institute in 2014, where his work scope involved understanding HIV evolution of drug resistance. He completed his PhD in 2021, and from what I understand in record time, here at UKZN, and his PhD work at ARI focused on understanding the 501Y.V2 beta variant and its escape from antibodies. Sandile recently led some of South African and global research response to COVID-19, including the studies that were first to isolate and characterize the live beta variant. With the Segal group, he was the first in the world to report the immune escape of beta and Omicron. He additionally led the study that described how variants can evolve in sub-Saharan Africa. Additionally, while most research groups use pseudo-style SARS-CoV-2, he developed a creative way to isolate live viruses from infected individuals. And who better to explain how this is done than by Dr. Sandile Cele himself. The work he has done since May 2020 has led to the publication of 3 first author papers, 2 in Nature, and this is like, the Ferrari of science journals, and 1 in Cell Host, a microbe journal. And sorry, I'm not a microbiologist or having something to do with biology, but I assume that this is also a very reputable journal. Sandile is also the 7th recipient of the National Bato Pele Excellence Award. And this is me, enough talking. I would now like to leave the stage to Dr. Sandile Cele when he takes us behind the scenes of COVID-19. Sandile, it's up to you now.
Thank you very much for that lovely introduction. So I'll try to share my screen. Tanya, can you hear me?
If I would unmute myself, I can hear you loud, hear you clear and loud. Thank you, Sandile.
All right. Thank you very much, Tanya, and good evening to everyone. Today, I will take you through a COVID-19 research conducted here at Africa Health Research Institute. So those who don't know where Indwedwe is, Indwedwe, okay, I can get rid of this. So Indwedwe is a small village that is like 30 kilometers away from King Shaka Airport. One can actually see the airport and the Palito shopping mall from home. So this is where home is. I attended at Mlandileni Primary School and later went on to Emashiamahe High School, which is about 5 and 10 kilometers away from home. So I moved from Indwedwe to complete my studies at Overport Secondary School, where I matriculated in year 2006 and enrolled at UKZN Westville campus in year 2007, doing a bachelor's in biological sciences. So year 2008, I switched courses from biological sciences to biomedical sciences and graduated in year 2009. I then went on to do my honors in medical microbiology and master's in biochemistry under the supervision of Prof. Bubuya Masola. So I've recently graduated with a doctorate in medical microbiology, and where my research project focused on SARS-CoV-2. So a COVID-19, a disease caused by SARS-CoV-2 infection has resulted in more than 6 million deaths worldwide, and more than 500 million people have tested positive for the virus. It is estimated that 10 times more people have contracted SARS-CoV-2. A number of people get infected but are asymptomatic, therefore are never tested. So the first cases of SARS-CoV-2 were reported in China year 2019. So with the first case reported in South Africa on the 5th of March, year 2020. So a team was organized at Africa Health Research Institute to conduct SARS-CoV-2 research. So the main concern for us was the high number of people living with HIV in KZN. So we hypothesized that people living with HIV would experience severe symptoms when exposed to SARS-CoV-2. So the team composed of a leading or principal investigator, Prof. Alex Segal, project managers who are responsible for overseeing different projects. And we also have nurses who help with recruitment of participants and also sample collection. And there are also scientists that plan and conduct experiments, while our research technicians help with processing of samples collected from our recruitment sites. We also have research collaborators such as CRISP, which is KwaZulu-Natal Research Innovation and Sequencing Platform. We also work with NICD in Johannesburg and also CAPRISA. So to work with viruses, one needs a laboratory approved for such work. So ARI has the following laboratories: a biosafety level 1 laboratory, where work can be done on an open bench and minimum PPE is required. We also have a BSL2 laboratory. So this lab is restricted behind self-closing doors, and personnel wear minimal PPE plus face masks, and many operations are performed within a biosafety cabinet. a BSc. And lastly, we have what we call a BSL-3 laboratory. So this is required when working in the presence of potential lethal or airborne microbes, such as tuberculosis and SARS-CoV-2. So the lab is restricted behind 2 sets of doors, and workers may require immunization, and PPE plus respirators are advised. So all work here is performed within a biosafety cabinet. So BSL-3 is a negative pressure room, meaning that the air pressure inside the room is lower than the air pressure outside the room. This prevents air from leaving the room when the door is open, thus limiting the spread of infectious agents out of the lab. So let's take a look inside the BSL-3 laboratory. Like to report that there's a diminished recognition to the new variant, then now that was a real breakthrough. Like even to communicate that, to say, listen, the people that were infected during the first wave, they might not be safe from the new variant. So that was a really big moment to say, okay, we have done something here. And boom, and started getting calls from the media, and people wanted to talk to us. No one has ever wanted to talk to us. Okay, that's enough of that video. Okay, basically I wanted to show you how it looks like inside a BSL-3 laboratory. Okay, there are 3 hospitals from which we recruit our study participants. So we have King Edward, which is closer to us, Clearwood, and Inkosi Albert Luthuli Hospital. So the nurses go to these hospitals every morning to recruit SARS-CoV-2 positive participants. Those who voluntarily agree to participate in our studies, a swab and a blood sample are collected and brought to ARI laboratories. So the blood samples are processed to separate red blood cells and plasma. So plasma is the liquid component of the blood that carries antibodies, which are essential in fighting infections. So the swab samples are used for SARS-CoV-2 isolation, and the isolated virus is used to test antibody efficacy and also identifying the infecting virus. So the virus is either sent to CRISP or the NICD for sequencing. So let's get to how is SARS-CoV-2 isolated. So one needs a SARS-CoV-2 positive swab and cells that are infected with SARS-CoV-2 a BSA-3 laboratory, and of course, a trained personnel to work inside the BSA-3. So inside a biosafety cabinet in BSA-3, Vero E6, which is a monkey cell line, I infected with SARS-CoV-2 and then incubated for 4 days. So 4 days post-infection, the virus is then collected and then stored. Then I'll explain later of how we use this virus. And then here I would like to thank CRISP, who provided us with the first samples, which we used to isolate SARS-CoV-2. So isolating the beta variant was not a success using the previously described method. So one needed to use a different cell type, which is a human cell line, H122E3. These cells were manipulated in a lab to have more SARS-CoV-2 receptors. Receptors are proteins on the cell surface that a virus binds to and infects. So the E3s were infected with SARS-CoV-2 and incubated for 4 days. Then the infected human cell line was then used to infect the monkey cell line. And then these were incubated for 4 days. And then again, after 4 days, the virus was harvested. And these samples were also provided by CRISP. I think they received these samples from Eastern Cape around October in 2020. So using the previously described method, the Africa Health Research Institute became the first institution to isolate the beta variant. So hope you can hear this.
Now, South Africa's scientists have been lauded internationally for their extraordinary work in tracking COVID-19 mutations. A 32-year-old from KwaZulu-Natal has done what no one else has been able to do up until now. Sandile Cele has successfully grown the 501YV2 COVID-19 variant, first discovered here in South Africa, and it's hoped this will help in the fight against the pandemic. Reporter Mwande Keswe sat down with him.
We tried about 6 samples from the hospital and none grew. Then we thought maybe the virus had adapted to humans. Then we tried to change a cell line that we had been using, which was a monkey cell line. We switched on to using a human cell line, which then we were able to grow the virus. And this puts us in a position whereby we have the virus in the lab and we could do all sorts of experiments.
It was this moment of genius that is now helping South Africa and the rest of the world to launch a relentless attack on COVID-19. And it's garnered global recognition for Sandile Cele.
As we were the first people to be able to successfully grow this virus, some institutes around the world have requested that we ship the virus to them. So we have shipped a couple of viruses to other institutes so that they could do their own research.
But how exactly will this breakthrough help in the fight against the pandemic?
Once we have the virus, we can start getting solutions, because we can start understanding. If you don't know your enemy, you don't know how to fight him. The lab is a starting point. So without actually growing the virus up, you cannot go towards a solution. You cannot find a solution without knowing the problem. And that's why this step, is what Sandile did, is so critical.
The Ndwedwe-born UK then graduate says he will keep donning his laboratory uniform to help better the country. Mwande Keswe, Durban.
Now, South Africa's scientists.
Okay, enough about that. Okay, now we had viruses and plasma samples to work with. So what next then? So we ran neutralization assays. So this assay is done to assess antibody ability to bind to SARS-CoV-2 and prevent infection. So these kinds of experiments or assays are used to determine a vaccine efficacy. So we use either a human cell line H1299 or a Vero E6, which is a monkey cell line. So we first diluted the plasma samples, and then to these diluted plasma samples, a SARS-CoV-2 virus was added, and then we infected the cells. And then this is incubated 24 hours or overnight, depends on the variant. Some variants we do 18 hours and some variants we do 24 hours. It depends on how fast that variant grows. Okay. So 24 hours post infection, we add the primary and the secondary antibody. This is to detect the infected cells. So I'm just summarizing this. I'm summarizing this. It's usually for each step, it takes about 4 to about 6 hours, and the whole experiment is done over 3 days. So this is how the infected cells look in a 96 well plate. I'm not sure if you can see this, but I'll just play a small, short clip which shows the infected cells. Yeah, I hope you can see that. So those blue dots are all SARS-CoV-2 infected cells. Okay. So now let's go through how to read or interpret these results. So on the first column here is a standard antibody that we know works well against SARS-CoV-2. So at higher plasma dilutions, 1:25, 1:50, and 1:100, there are few infected cells, like 4, 7, and 21. This means that the antibody can bind to SARS-CoV-2 and prevent infection of the cells. So on column 11, we have what we call a positive control, when no plasma was added, just cells infected with SARS-CoV-2. Hence, even at higher antibody dilution, we get high numbers of infected cells, like this 83, 110, and 108. So column 2 to column 9 are our participants that we are testing. So participant 1 and participant 6 have a high number of infected cells at higher dilutions. So based on these observations, these 2 participants are considered poor neutralizers or bad plasma that doesn't bind to SARS-CoV-2. The remaining participants are considered to be good neutralizers, as their plasma is able to bind to SARS-CoV-2 and prevent infection. So for presentation and publication purposes, the results are further analyzed and represented in such graphs. Okay. So the example presented here, we tested plasma samples taken from participants before and after getting vaccinated. And these were tested against the Omicron variant, which is currently circulating in South Africa. So when the neutralization number is low, the plasma is considered to be bad. And when the neutralization number is high, that plasma is considered to be good. So from this experiment, we can see that these participants before vaccination had a low neutralization capacity against Omicron. So, and after vaccination, the neutralization capacity of the plasma has improved from a mean of 6 to about 447, almost 70 times. So this is how you actually interpret these results. So I don't know if we still remember these headlines where South Africa suspends the use of AstraZeneca vaccine after it fails to clear or stop the virus. So these statements were true. And the Africa Health Research Institutes played a crucial role by running neutralization assays to assess whether the AstraZeneca vaccine works against the Beta variant, which had just been identified in SA late in year 2020. So here on your right are neutralization results generated in our laboratory. The B1117 is the original SARS-CoV-2. And we see that AstraZeneca works well against it. We see that by high neutralization numbers. Then here it's B1351. This is the Beta variant. And you can see that the neutralization numbers are very low for the Beta variant, meaning that AstraZeneca does not work well against the Beta variant. So a group in Gauteng, I think it's Penny Moss group from the NICT, they also found like similar, they had similar findings showing that the Beta variant escapes neutralization by AstraZeneca. Yeah. So based on these findings, a decision not to use AstraZeneca in South Africa was taken. Let's see if we can play one of these.
So it's a temporary issue that we have to hold on to AstraZeneca. It is temporary until we figure out these issues. What are the next steps supposed to be? When we know those steps, then of course we bring it back.
Let's this. We have to cover some other stuff. Okay. So now I would like to share with you a case study of an individual that was infected with SARS-CoV-2 and remained infected for more than 200 days. Usually SARS-CoV-2 is cleared in less than 2 weeks after infection. But in this case, the participant was hospitalized with high HIV viral load. So the blood and the swab samples were collected throughout the duration of SARS-CoV-2 infection. So the swab samples were used to determine the infecting SARS-CoV-2 variant and whether this evolves over time. So blood samples were used to test for antibody ability to bind to SARS-CoV-2 and also to measure HIV viral load and levels of antiretroviral therapy drugs that the patient was taking. So following failure to control HIV over time, the doctors decided to change the patient's ART regimen. So after changing the regimen, we saw a drop in HIV viral load, which was followed by a clearance of SARS-CoV-2. So however, one thing had changed in the SARS-CoV-2 virus that infected this patient. Here on day 0, this is the infecting virus. It's only had like 3 mutations: the G142V, D614G, and D796Y. These are genetic changes in the virus. No need to stress about it. So the point I'm making here is that the virus kept changing within the infected patient who struggled to clear it. So after 190 days of infection, we ended up with a different virus from the infecting virus. It had acquired 5 more mutations. So what does this mean? What do these changes mean? So we're able to isolate all these viruses that were collected on different days and ran neutralization assays to determine what these changes meant. So we tested the most evolved virus. This was the virus collected after 190 days, and tested it against plasma collected from different infection waves, which is ancestral or original, beta and delta plasma. So the most evolved virus, D190, had gained advantage of escaping neutralization by different plasmas, meaning that changes on the virus had allowed it to be more infectious and escape neutralization. So using the previous neutralization data, we could map that the virus isolated from, we could map the virus isolated from our immunocompromised participant. So we saw that the infecting virus, this is D0 virus, was close to the original, D614 is the original SARS-CoV-2. So the early virus or infecting virus was close to the original SARS-CoV-2 virus. However, 190 days of infection allowed the virus to change to be a beta-like variant. So these results suggest that failure to clear a coronavirus gives it a chance to evolve and be more dangerous or more infectious, and also escape immunity. So our recent result or groundbreaking work was the ability to isolate the Omicron variant, run neutralization assays, publish a scientific manuscript, all in less than a month. So these are some of the publications that I have. The last one, Omicron extensively, but incompletely escaped Pfizer neutralization. This was published on the 23rd of December 2021, and I started this work around 20 November 2021. So it took us about a month to isolate, run assays, and write a paper, submit for publication, and the paper was accepted. So I would like to thank my colleagues, our principal investigator, Prof. Alex Segal, project manager Khadija, Afra, Zesuliwe, Uyashika, Ukajali, Laurel, and Mallory. And of course, I would like to thank myself as well, Sandile Cele. And I would also like to thank the Minister of Public Works, who invited us to receive a special COVID-19 award. It's the 7th National Batopele Excellence Awards.
And the greatest efforts in combating the COVID-19 pandemic over the past 2 years, contributing not only to the country's ability to keep the growth of the pandemic in check, these individuals have opened up world-renowned research findings. Our NBPEA 2022 Special Recognition COVID-19 Award recipients are Mr. Sandile Cele, a bioscientist who isolated the Omicron variant from the Beta variant. South Africa was the first to report about the Omicron variant between November and December 2021. Professor Helen Maurice.
And thank you everyone for listening. Thank you so much.
Thank you so much, Sandile. That was highly interesting, because I mean, I've just recently been to your lab. I don't actually know what went on behind the scenes, and I really appreciate that you opened the door for us. And I also like to thank Ari for opening the doors to us and let us behind the scenes. So I'm pretty sure that there are many questions, but you know, being the host of the evening, it's always my pleasure to have the first questions.
Yeah.
And I always find it interesting to see. I mean, you've just finished your PhD in a year's time. Do you think without COVID that would have happened?
A year, 6 months, not a year's time.
Oh, okay.
1 year, 6
But
months.
still, you know, I mean, for everybody who's done a PhD, this is like, I would say, a record time. Do you think that COVID was a good opportunity for you, or you would have rather preferred to work on HIV, continue working on HIV?
I think COVID really gave me a chance, because there were so many projects that one could do. You would get into a project and then you finish it, you write, and then you have a publication. And as soon as you finish, there's another project to take on. There was so many projects. So it's dependent on how fast one could work. So someone else maybe could have wrapped it in a year. The way there were so many projects. So there were projects after projects. So it's way up to an individual on how fast they wanted to get the work done.
Thank you. And I have to apologize if I address you as Mr. Sandile Cele, because you are actually Dr. Sandile Cele. So my apologies if I you know, misplaced this. Thank you, Ntakosu, for putting this right. Are there any other questions from the audience? Come on, guys, this is your chance. Here we have a celebrity. Lungisile, you wanna ask a question?
Yeah, we were
Yes. Hi, Dr. Cele. So this is very interesting work that you've done. I'm just wondering, you know, looking at sorry, I come from the clinical side of things, but looking at the background or the history that the fatality of COVID-19 is about 1% of the world. Did you guys maybe find any data or give any information on what our fatality was? Or does it look like a patient that had 6 months or 7 months to clear the virus?
Yes, Swami, you're breaking up, but your question, I really want to answer your question. I think it's very interesting, but I cannot hear you.
I'm on the road. Okay, so did you guys find anything with regards to the fatality, the rates, the death rates of COVID? Did you find anything different to what the world is saying? You know, and your patient with the 7 months of COVID, did he clear it ultimately?
Oh yes, I can talk more on that on the patient. You know, the patient they subsequently cleared SARS-CoV-2, but that came after the doctors have decided to change the ART regimen. They switched it to a DTG-based regimen, and then when the viral load, the HIV viral load dropped, the patient was also able to clear SARS-CoV-2. I think it was the immunosuppression that allowed SARS-CoV-2 to persist. I'm not sure if that answers your question.
Yes, you have. Thank you so much. I'm on the road. I think I didn't hear some parts, but yeah, it makes sense. We would see so it means going forward, you've got more studies to do with regards to immunosuppression. Do you have any data on the death?
Lungisile, I think you're breaking up. I'm not too sure.
I think she's saying that if you have any data on the death rates of South Africans.
Death rates is in death rates amongst the immunosuppressed participants, or death rates is
like the immunosuppressant participants in your study.
The thing is, we don't have that many immunosuppressed participants in our study. There are a few, so we really can't put statistics.
Thank you so much.
Yeah. And Sabonga
Thank you very much.
for logging in, even though you're on the road. Sabonga, cool. We appreciate it.
I know there's a couple of questions in the chat. There's one from Tafatswa Nawanda. Do you want to ask your question yourself, or do you want me to read it out? Tafatswa? Okay, I think there's somebody very shy, or
they can read them out. Can read it out.
okay. So he's asking, well, what is actually your motivation? What motivates you to do this?
Oh, because it's just if I don't do it, who else is going to do it? So it also motivates me that with doing research that you see the immediate impact. Like some of people who are doing research, it takes time then to see what you have done and how it has helped. For us, it's been doing the work now and then impacting on very serious decisions. Like you see it, the immediate impact of what you have done. So that's what has been pushing me.
Okay, I have to, no, sorry, I'll have to, I'll take the liberty to ask you a follow-up question on that. Has there been any moment in your research where you're a little bit scared about, you know, your health conditions, your life? I know that you wear all these hazmat suits and whatnot, but, you know, I can seriously see that, you know, these kinds of things are really, you know, I think nerve-wracking, I would say, to deal with these very dangerous viruses.
I wouldn't lie, but the first time, the very first swab sample that we received, that I had to go into the lab with, there was that it's a new virus. I'm going to work with. I'm going to open it up actually. So there was that. But after that, remember, here at Africa Health, we have been working with HIV. We have been working with tuberculosis, and we have laboratories that are set for working with such. So really, it's not a big deal to me. I think one stands. One can actually get the SARS-CoV-2 outside the lab. The probability of getting it is higher outside the lab than inside our laboratories.
Okay, yeah. Sally is gonna has a question, and then after that we can ask Myra to.
Sandile, I just wanted to know what you're working on right now, your current project.
My current project. Am I allowed to say my current project? My current project. So for now, I'm looking at people that have been vaccinated, who received Pfizer vaccination, and who were also infected with the ancestral virus, looking on how well they deal with the other variants. And then comparing that group to people who are vaccinated, but infected with the beta variant. We want to see which ones have the stronger immunity. But that's, I'm actually finished doing experiments on that. I'm writing up. Yeah, I'm going to take another project in a couple of days.
You sound like a very busy man. Myra, and then Mayibongwe, please.
Yeah, I just wanted to know how your clinical trial went with regards to the variant vaccinations that you passed out. Like, did you test them according to like different continuant strains, or did you like just try different participants who received viruses and vaccines and have shown symptoms? Have you been doing that as well?
Clinical trial. No, I think we have what we call a cohort. So then our nurses just go to our recruitment site, and whoever has tested positive there, then they try to recruit them, and then we follow them we follow them, like we go after a week, and then after a month, after 6 weeks, and so forth. And then during the
So
course
did
of,
you and
they get
did you treat
vaccinated
any?
after having
Yeah.
enrolled.
Oh, they got vaccinated after getting enrolled, and which
Yes,
vaccine did they take?
exactly, yeah. So once we get the swab samples at enrollment, we are able to send it to CRISP or NICD to get what's the infecting variant. And then at follow-up time points, we also collect swab samples to see if maybe there are reinfections. We also see what kind of variant is infecting at that time point. We collect the blood as well and see how their antibodies are. So it's a long study. Some people we've seen for more than, I don't know, it's been a year now, 6 months. So we started collecting samples around June 2020. So there are participants that we followed up for more than 18 months. Every time they come to the clinic, we take a swab and we take blood samples.
Which vaccines did they receive?
Different vaccines. We have people who got J&J, we got people who have Pfizer.
And how did they correlate, like in between the groups? Like, how did you feel?
That is a study on its own, but for now we have been just using this opportunity to collect as much samples as we can. Then we're gonna analyze. Yeah, so it's not just me in the lab. I have my own parts that I play, and then some people are doing other projects. But from time to time, then we have meetings whereby everyone updates on where they are.
Okay, there's still some more questions. Mayubongwe, Abel Nkandla, do you want to ask your question? And then Neo Sigona, please. Mayubongwe?
Okay, could you please, could you please ask for me right now by the team? So I'm following up what is by the team. That's how I'm typing also. Okay.
Sorry, I didn't quite get it.
Okay, I can read out.
Okay. So how did the participant able to have lived SARS for 120 days, where it's been proven for it to be virulent for less than 2 weeks?
Excuse me, can you repeat that again?
So he's basically asking why the live SARS was so long for 120 days, where it's been proven for it to be virulent for less than 2 weeks.
I don't think it has been proven to be whatever for 2 weeks, because whenever we met the patient, I think on the slide that, maybe let me just go back and show this. So we collected samples at day 0, that's its enrollment, day 6, day 12, day 34, 71, 106, and 190. We were able to isolate a live virus here. So I have proof that even at 190 days, the virus was still live. If it wasn't live, I would not have been able to isolate it or grow it. You can't grow a dead virus. So I know for sure that at 190 days, the participant was still sharing a live virus.
I hope that answers your question. Neo Sigona, do you want to ask your question?
All right, good evening, everyone. Thank you so much, Dr. Cele, for the nice presentation. So my question is not necessarily related to your presentation, but I just want to know if, do you think the metabolism of each individual play any role on the vaccine response?
I hear you very well. I think your immune system, like we all respond differently when it comes to vaccination. I'm not sure if that answers your question, but I think everyone will respond differently to vaccines.
Yes, my question is, do you think metabolism could be one of the reasons why each individual would respond differently to the vaccine?
I'm not sure. I'm not sure, my sister. I don't want to lie to you. I'm not sure about that if metabolism plays a factor there. I'm not sure about that.
All right, thank you.
Ngiyabonga kakhulu.
And we have two Siyabongas, Siyabonga Ntombela and Siyabonga Peter after that, who wanted to ask another question. So you're a popular man, Dr. Cele.
No, it's all right. It's all right. I'll take all the questions.
Okay, hi everyone. My question was, as you research on this thing about COVID, was it easy for you to convince your family to get vaccinated?
Ish. At first, yeah, it was very difficult, especially that I spent most of my time here at work, so I didn't see them very often. But whenever I went home, I would try and talk to them. It took time, but eventually they got the jab.
Okay, because yeah, I know that most people they had that hesitant first.
Yeah,
Oh, yeah.
it was bad. Yeah. But yeah, eventually I'm glad eventually they listened, and then we all got vaccinated.
Okay, thanks.
Siyabonga Peter, you want to ask a question?
Yes, thank you very much for the presentation, Dr. Cele. I just wanted to ask, man, has there been any advances made, to cure the HIV and AIDS? Any study that you might have come across during your research, something like that?
A study that looks at?
Look at something that can cure the HIV and AIDS.
That can cure HIV and AIDS?
Yes.
Oh, my brother, no, I'm not going to lie to you. I've read a lot of papers during the last 2 years.
Yes.
I've never came across with such study that says, yeah, but there are promising vaccines that people are looking at. Okay. That's, of course, it's in terms of prevention, not necessarily cure.
Oh, okay. I know. Thanks, Maka. Siyabonga mfethu man. Ngophakamise iflag yomZantsi Afrika. Thanks a lot.
Thanks.
Sure.
Okay, so I think we're coming closer to the end. I think Timbelani Kumalo and then Mayibongwe Abel Mkandla is going to give the last questions to you. Timbelani?
Okay. Good evening, everyone. Thanks, Doctor, for the good presentation. My question is there, how about the risk to face the same or the similar viruses like this? And if the risk is high, there is a plan maybe in place to prevent this before introducing lockdowns or things like that.
Oh, I think the best thing that we can do is whenever there is an identification or we come across a new virus or whatever infecting agent, is to not to let it spread before we can take action, is to act as soon as we identify something new and see if we can just isolate it and deal with it there before it spreads. Yeah, that's all I can say on that.
Yeah, no, they're scary thoughts, I have to say. Going through this again, not really fun. Mayibongwe and Mampo, if you I know that if I'm going to leave the questions on, we're probably going to sit here all night. So Mayibongwe and then Mampo is going to finish off with the last question. Oh, Mayibongwe, you want me to read it out again? Okay, question from Mayibongwe Abel Mkandla is, do you think natural immunity from the ancestral strain played a part in neutralization of the virus as compared to effectivity of the vaccine on the progressing strains?
I think the first publication, our first publication looked at how people that were infected with the ancestral virus, how they were not responsive to the beta variant. I think those who got exposed with the, who were infected with the ancestral virus were susceptible to get infected with the other variants compared to people who just got vaccinated. I think the original virus didn't elicit that much immunity that could prevent reinfections. I'm not sure if that's if maybe it answers his question. I see that. I don't know if it answers his question.
Can you
But
just
we
do
can
a
ask a
thumbs up
follow-up.
if it does answer your question?
Or a follow-up of some sort, then we talk.
Okay. If we don't get an answer, maybe Mampo Motsi, you can ask the last question.
Okay, thank you so much for this opportunity. It's not a question, but it's just a comment. It's Mampo from Lesotho. So I think I feel so excited today. At least one has gained knowledge as how the Omicron variant was discovered. We were just told that Omicron has been discovered in South Africa. How? No one knew. That's why I got very interested when I got the mail on this topic. So Sandile Cele, we really thank God for whatever you did. God bless you. Thank you so much, team.
Oh, wow. Thank you so much, sis. Oh, what a lovely closing to this session.
I would say this is an absolute perfect closing to the session. Yeah. And I have to agree that, you know, without the work of how do they say basic science? And I think it's way more than basic science. That, you know, we wouldn't be there without you guys. Thank you so much. Yeah, okay, so this brings us to the end of the lecture, and I would like this opportunity to thank a few people. Of course, Dr. Cele, you for your absolute fantastic presentation. And I have a comment here which I want to read out because I think that's you were afraid that it's too, you know, not scientific enough. And let me just find it for you. From Robert Suberg to everyone, thank you for your presentation. I could understand what you were saying from a person who has no degree. So, and I think that was basically what this is all about. To just sometimes you have to go a step backward and make simple people like us understand, you know, what is actually going on behind the scenes. And also our guest speaker from Lesotho also, I think, quite nicely put it. Then I would like to thank a couple of more people. Roanne Peters from the African Health Research Institute. Without her, you wouldn't be here. She did a fantastic job also, you know, for inviting learners to the lab. And I was very fortunate to visit your labs, and I found it really, really interesting. Marianne Francis, who basically initiated this great opportunity and put us together. The researchers, of course, the lab technicians at ARI for their help, and very much appreciated. You know, we disturbed their routine and they were there. Dr. Sally Frost, who coordinated the event, to Asok Raj, who designed the invitations and the wonderful backgrounds, the DSI and SASTA for providing such a great opportunity to highlight science and engineering, and the countless people in the back who helped spreading the message. And just please remember, tomorrow evening, we have another exciting talk coming up by another very young scientist, Ms. Zakita Mkize, on doing HIV research in the lab. The hunt for the cure continues. And I think there maybe a couple of questions might be answered as well. Thank you, everybody, for joining us and for being with us. And thank you, Dr. Cele, again, for this absolutely fantastic talk and for providing us an insight and really taking us behind the scene. Thank you, everybody, and a good evening to everybody. Thanks.
Bye.
Thank you. Bye.
And maybe, you know, usually when we would be live, we would give him a round of applause. If you want to unmute yourself, and I think this deserves a big round of applause. Please, everybody, if you just want to join me.
Thank you.
Thank you.
And I really hope that at
you.
one point, when this is all over, we have a real life, you know, lecture in the Science Center. Thank you so much, everybody, and good evening.